Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is the second point in section 7.5, and it's about permutations. Number of permutations is the number of possible arrangements. For example, in example 3, here, we had 8 people and we wanted to choose 6 of them in order, or we needed to arrange 6 of them, 6 places only out of 8. So we always have 8 number and we need to arrange 6 out of 8. Okay, or we say number of permutations of 8 things taken 6 at a time. This means that we have 8 things and we need to arrange 6 of them. So we call this 8p6. We write it like this. We can also write it like this, 8p6. It is in the calculator. There is a special button in the calculator above the cross, the multiplication, in yellow, NPR, in which you put 8. You write 8 first, then you press Shift X, or the product, the multiplication, and then you write 6. So you will see in the screen 8p6. The definition of 8p6 is n factorial, 8 factorial over 2 factorial, or n factorial over n minus r factorial. So what is 2 here? It's 8 minus 6. So this is the definition of NPR. It is n factorial over n minus r factorial. So the number of possible ordered arrangements of R objects chosen from a set of n objects. So try to understand this carefully. We have n objects and we are choosing R of them, but in order or in arrangement. So there is a difference between each of these R objects because there is an arrangement for each one of them. The order is important here. So if the order is important, if there is an arrangement, we call it the number of choosing R of n is called number of permutations of n objects taking R at a time. And we write it in PR. Now notice that in Bn, according to this definition, n Pn would be n factorial over n minus n, which is 0 factorial. And we have seen that 0 factorial is 1. So nBn is just n factorial. What about np1? Well, np1 is n factorial over n minus 1 factorial. But n factorial is n times n minus 1 factorial over n minus 1 factorial. And by cancelling, we get n. So 7p1 is 7. 6p1 is 6. While 5p5 is 5 factorial. npn is n factorial. Okay. Some examples. In how many ways can a president, vice president, secretary, and treasurer, how many people? 1, 2, 3, 4, be selected from an organization with 20 members? So we have 20 members and we are selecting 4 of them, but in an arrangement, there is an arrangement. One of these 4 would be a president. The second one would be vice president. So this is the arrangement we are talking about. You can answer this question by 2 different methods. Either you use the fundamental counting principle, and please refer to the previous video for that, and you have 4 people to choose. And you can say, in how many ways can I choose the president, the first one, the first person? Well, I have 20 people to choose from. And if you choose the president, now choose the vice president, and you have 19 people left because we selected already or we chosen the president. So you can answer this question like this: 20 times 19 times 18 times 17. But also you can think of it as a permutation. You are selecting 4 out of 20 in order. So the answer is 20p4. And 20p4 in fact is 20 factorial over 16 factorial. And 20 factorial is 20 times 19 times 18 times 17 times 16 factorial over 16 factorial. So it's in fact similar to this. So this is another point to put it in your mind. In fact, 20p4 is you start from 20, you multiply 4 numbers because of this 4. So for example, 7p2 would be 7 times 6. 2 numbers. 7p1 is 7. 7p2 is 7 times 6. 7p3 would be 7 times 6 times 5. 3 numbers, and so on. Okay, so this will help you in computing the permutations even without a calculator. In a 5-question matching test, you have questions and answers, and you match them. Okay, how many different answer sheets are possible if no answer can be used twice, and there are 5 answers available for matching? So 5 questions and 5 answers. So also you can use always you can use fundamental counting principle with permutations here. Now we need how many different answer sheets are possible if no answer can be used twice. No answer can be used twice. And there are 5 answers available for matching. So we need to match questions with answers. We need to choose, we have 5 questions. So we will select 5 of them with arrangement, with order to match. Okay, so really we are selecting 5 out of 5. So it's 5p5 or 5 factorial. Uh, you can answer it using the fundamental counting principle. In how many ways are there, how many answers are there to choose for question 1? 5. And if you select one answer for question 1, how many answers left for question 4? 4, and so on. So it's actually also 5 factorial, because here uh, there is an arrangement. 7 answers available for matching. Now you have 7 answers available, but you need 5 of them only. You need to select 5 of them only. So selecting 5 out of 7 in order is given by 7p5. 7p5. Or here you can solve it by fundamental counting principle. Now you have, for the first question, you have 7 possibilities. For the second, you have 6 until the 5th question. So this would be the answer. And it's exactly equal to 7p5. Now here another question. 8 horses are entered in a race. In how many ways can the horses finish? So we have 8 horses and they will finish the race. So one of them will come first, then second, third. So the order is important here. So 8 factorial or 8p8. Or you can use fundamental counting principle. The first horse who comes first, there are 8 possibilities because 8 horses. Then the horse in the second position, there are 7 possibilities and up to 1. So it's actually 8 factorial. 4 candidates for manager of a department store are ranked, ordered, arranged according to the weighted average of several criteria. How many different rankings are possible? Rankings immediately use permutation. If no two candidates receive the same rank, we have 4 candidates, okay, and we need to rank them. So who comes first? There are 4 possibilities. Second, 3 possibilities, 2, 1. So it is actually 4 factorial or 4p4. We are selecting 4 out of 4 with order, with arrangement. An examination consists of 12 questions. 10 questions must be answered. So you answer 10 out of 12. Find the number of different orders in which a student can answer the question. So there are 12 questions and we need to select 10 of them in order to answer. So the answer is 12p10. Or you can say this is of course 12 factorial over 2 factorial or 12 times up to 3. You can solve it using the counting principle. You can think of it that I need to answer now 10 questions only. I have 12 questions. So let me choose the first question to answer. How many choices are there? Well, I have 12 questions to choose from. Okay, I answered the first question. Now go to the second question. How many questions left to choose from? 11. And so on up to 3. So this would be also the answer using the fundamental counting principle. So permutations, you can solve them using the fundamental counting principle in 2 different ways. A member of a family of 4, so family of 4 people there in the family, wife, husband, 2 children, is asked to rank all members of the family. Rank the first, second, in the order their of their power. So first, the highest power in the family, the father or the mother, for example. 1, 2, 3, okay, 4. How many possible ranking? We have 4 people. We need to rank all of them. So it's really 4 factorial, okay? Or you also can use the fundamental counting principle. The most powerful person in the family could be 1 of 4. Then the second 3, the third 2, and 1. So these are some exercises about permutations. I hope you understand what we mean by permutation.